So everybody, this example we're going to toss 2 coins and we're going to roll 7 dice. We're going to figure out the possibility of getting 2 tails and then all 6s on all of the dice, right? So let me find 7 dice. Here's 1, here's 2, here's 3, here's 4, here's 5, 6, and 7. There's 7 dice. So I've got to go tail. Oh, I got tail. Great. I'm on a good roll here. Oh, that's a head. Now I'm done. But if that should have been a tail as well, then I need to get a 6 on that. 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 I need to get a 6 on that, 6 on that, and 6 on that. That didn't work out. This is quite unlikely. It'd be pretty hard, I hope you can see, to pull this off, right? Trying to get a tail. So everyone, while I'm playing here and trying to do it, you guys see if you can calculate it. So everybody calculate the probability as I try to do this. Oh, I got 2 6s. But that's all. So yeah, see if you can calculate the probability. And these are independent events because they don't depend on each other. Like this dice, the outcome of this dice doesn't depend on the outcome of this dice or whatever, right? So what do we think? We got an idea how to do this? Right. Right, so it's just similar to the last examples, like when we had 2 coins and 1 dice. What do we do, right? Right, so probability of getting a tail on the first dice. So the first coin, the probability of getting a tail is 1/2. On the second coin, the probability of getting a tail is 1/2. On this dice, the probability of getting a 6 is 1 out of 6. Same for this dice, the probability is 1 out of 6. Same for this dice. Same for all 7 dice. For each dice, probability of getting a 6 is, well, it's 1 out of 6. Right? So for each dice, the probability of getting a 6 is 1 out of 6. Well, I guess I'll put them over the 6s. But, you know, there's a lot of possibilities. There's a lot of things that could go wrong here. A lot of things that could go wrong. How about you sell your house and bet on an event like this? Would that be a great idea? I mean, okay, don't bet your children on this either, right? Not a good idea. This is not a good idea. This is an unlikely event. Look at all the things that have to go right for you to get the outcome you're looking for, and all the things that could go wrong. Now, if the thing about it is these are independent events, so to get the probability of each one happening in a row, all I have to do is multiply the probabilities. So I just multiply all of these probabilities, and I multiply all these fractions. In other words, multiply all the 1s, and I get 1. Multiply all these, and I get, 2 times 2 is 4. And so this becomes basically, 4 times, and this is 6 to the power of 7, right? And so I can use my calculator here, and yeah. And I guess I could go 1 over parenthesis 4 times 6 to the power of 7. That's one way of doing it. 1 over parenthesis 4 times 6 to the power of 7, which is this number. 0. Yeah, it's very unlikely, right? What's that as a percentage, by the way? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 8, 9, 3. What's this as a percentage? So to try to remind yourself, like 0. If you had, say, something like 0.05, what's that as a percentage? 0.05 as a percentage is what? Yeah, because we just moved the decimal point 2 spots to the right, and we get 5%, right? So all we have to do here is just move decimal point 2 spots to the right, and it becomes 0.0, and there's 4 zeros now, right? Right? So it's that. A very low probability, a very low percentage, right? Almost zero, very unlikely, right? And in fact, just for fun, 4 times 6 to the power of 7 is 100, and it's that number. So, by the way, this is 1 over 1119744, right? And what is that number? Put in the commas here. So this is a comma here and a comma here, right? So what number do I have here? What's this number? A million, 119,000. So it's a little over 1 in a million, right? So in other words, what we have is over 1 in a million. It's what you would say if you were just chatting with somebody about this, right? It's over 1 in a million. Got it? So very unlikely, okay? Because you have so many events that have to happen in a row, right?